Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So in this video we are going to learn about energy band gap. Okay, so energy band gap. If you are first time to my channel, please consider subscribing. Right, so energy band gap. This type of question maybe there is a chance to ask in the exam, right? So in 2019 December we have a question on this. Okay, so what is energy band gap? So energy band gap is the energy required, that is external energy which we have to provide, in the form of thermal, right, heat by increasing the temperature, or optical, any type of etc., right, any type of external energy which we have to provide for a semiconductor to excite an electron in valence band to conduction band, that is to make an electron free. Okay, so to make an electron free, how much energy we want to supply, okay, for an electron to excite from valence band to conduction band is termed as energy band gap. Okay, so that is the thing. So energy band gap, so the first point which you have to remember is energy band gap values for germanium and silicon. So I'll write in a form of table at 0 degrees Kelvin and 300 degrees Kelvin. So we know that T is equal to 0 degrees Kelvin or minus 273 degrees centigrade is called absolute temperature, because sometimes they may give it as at absolute temperature what is the value of energy band gap for germanium or anything. Okay, so you have to remember this. So what is absolute temperature? And T is equal to 300 degrees Kelvin or minus 27 degrees centigrade is called as room temperature. So they may ask you at room temperature what is the values. So you just have to remember these two. Okay, so for germanium at 0 degrees Kelvin its value is minus 0.785 electron volt. So the energy band gap units are electron volts, right? So at 300 degrees Kelvin its value is 0.72 electron volt. Similarly for silicon it is 1.21 electron volt and this is 1.1 electron volt. So second point which you have to remember is, as you see from this point, as temperature increases from 0 degrees Kelvin to 300 degrees Kelvin, the energy band gap is going to be decreased. So second point is energy band gap is inversely proportional to temperature. That is, as temperature increases, energy band gap decreases. This is the second point which you have to remember. Okay, and third, because there is no energy band gap, so energy band gap is almost equal to 0 in the case of conductors. So in this conductors, valence band and conduction band overlap with each other. That we'll discuss in another video. Okay, no problem about that. So we'll confine ourselves to energy band gap. Right, so what is the generalized formula? This is very important. This question is asked in 2019 December exam and also in some of the other previous exam papers also. Okay, so what is the generalized formula for germanium and silicon? So eg of t is equal to 1.21 minus 3.6 into 10 to the power of minus 4 t. Okay, so electron volt. This is the generalized formula in the case of silicon. Suppose if you take in this expression, if you take T is equal to 300 degrees Kelvin, okay, so if you substitute T is equal to 300, you will get Eg of 300 degrees Kelvin, that is energy band gap at 300 degrees Kelvin, as 1.1 electron volt, which is this value. Okay, that means using this formula you can find the energy band gap of silicon at any given temperature. These are the standard temperatures. So we can remember only two values, but we can't remember all the values at any given temperature. But we can find the energy band gap value at any given temperature using this formula. Okay. So similarly for germanium, Eg of T is equal to 0.785 minus 2.2 into 10 to the power of minus 4 into T electron volt. Similarly, if you substitute T is equal to 300 degrees Kelvin, you will get Eg of 300 degrees Kelvin as 0.72 electron volt. Okay, so when you substitute T is equal to 0, that it is at absolute temperature, you will get 1.21 and 0.785 respectively. Okay, so this type of questions are asked in the previous exams, so remember these points. Okay.